I hope this study guide video will help you get ready for Thursday's quarter 3 benchmark exam. All right, first problem says the object was reflected over the x-axis. So this was the pre-image before the reflection. This is the x-axis. It's reflected over. This is the image after the reflection. It's saying which angles are congruent. Congruent is a fancy word for equal. So we look at number 1. Angle A. Is this angle equal to angle E over here? You could say that is not true. Angle A is equal to this angle D right here. B says, is angle C equal to E? And yes, you could see those two are equal. So I will circle that one. C is wrong because angle B is congruent to this angle down here, F, but this choice says angle B equal to D, and that is not true. But you can see equal, equal, congruent. These two are congruent. These two are congruent. Congruent also means length. The length of this side is equal to this side, congruent. The length of this side, AB, is congruent to DF. These symbols mean the inside angle. But angles and length, when things are congruent, are all the same. Number 2, it says given the two, or using the diagram, give the two transformations. So this is the original, the pre-image. I am first looking like I'm just sliding it to the left. It's not rotating, it's not translating. So the first transformation is a translation. That's a slide. And it is moving 1, 2, 3, 4, 5 units left. 1, 2, 3, 4, 5. So translation, 5 units left to get to this first image. And then from this image to get to here, it looks like I'm reflecting over the x-axis. So from here, reflected straight across that x-axis. So my second transformation is reflecting over the x-axis, not the y-axis. This is the y-axis up here, reflecting over the x-axis. All right, number 3. This says, using this diagram, the scale factor of this dilation, this is the original, this big object right here. It is shrinking down to this. So the pre-image before the dilation, the Q1 is the image after it was shrunk down. So I know since it's going down, this choice already is bad because that's saying it would be going up by 2. But of these two choices right here, what I'm going to do is just focus on one part of my graph. So if I see what that is for x, 1, 2, 3, 4, 5, 6. If I multiply that by one of these, I should get the new x right there. So the trick is, what number, which of these fractions, these factors, times 6 would give me this number 4 right here. So if I want to do algebra, I could say, what number times 6 gives me 4? And if I divide that by 6, I get the answer, which is 4 over 6, which reduces to 2/3. I could also show 2/3 works if I take 6 and I times by 2/3. That gives me 12 over 3, which is 4. So if I take that point right here for the pre-image and multiply by 2/3, it's shrinking down to 4. If I want to prove this to myself, I could look at this value for y, 1, 2, 3. The original value is 3. If I take 3 and times by that same dilation factor, I should get the new y right here, which is 2. Let's see if that happens. So straight across gives me 6 over 3, which is 2. So yes, this is the correct dilation factor. It is shrinking down by a factor of 2/3. I know that's a little complicated, but I know you guys are smart enough to do that. Okay, number 4 is a rotation. I will give you patty paper for this. It says rotate 90 degrees, which is a quarter turn, counterclockwise. Remember, the clock goes this direction, but I'm going counterclockwise about the origin. That is the middle. So I take my tracing paper, trace the edges of that pre-image. I'm going to label the parts the same. I'm going to find the origin right there in the middle. I'm going to draw a orientation arrow straight up. And what I want to see, I'm turning this 90 degrees counterclockwise to the left. So I'm going to watch that arrow go until it goes a quarter turn to the left, counterclockwise. And it stops right there. I'm going to take my paper and really gouge these points, so when I lift my paper up, I'll know exactly where those points are. I'm almost even drawing through that paper so I can see when I lift it up. And let's do that one more time. Let's double check. Let's fill those in a little bit harder. I can see I have a point right here. I have another one right here. And then my last two, I'm going to fill those in real good. Almost go through the paper. You have as much of this tracing paper as you want. Those are my two other points. I'm going to connect them and label the new ones. So this right here is the new U. Up here is the new V. Right here is the new W. And then down here is the new T. It's asking what is the new location of V after the rotation. So if I'm looking at it, the new location of V after I rotated this is this point right here. So that coordinate is -1. 1, 2, 3, 4, -1, 4. So again, I drew my original. I rotated it 90 degrees to the left. And then I looked and see where this new location was for V. That's how you do number 4. Backside. Number 5 says dilate it and then rotate it 160 degrees or 180 clockwise, which is this direction. So if I dilate it, I'm going to take each point and multiply both by 4, or I'm sorry, by a half, which is my dilation factor. This point right here is 4, 5. This is 6. 1, 2, 3, 4. 6, -4. So if I take that and times by a half, half of 6 gives me 3. Half of -4 gives me -2. So the new C will be the point 3, -2 right here. That's dilated down. That's the new C. If I take B, B right here is the point 0, -4. A half times 0 is just 0. A half times -4 gives me -2. So that's the new spot for B, 0, -2. If I look at A, which is the origin, that times a half, 0, 0, this gives me 0 again. So A is not going to change. But now what I need to do is trace that new A, because again, A and A prime are the same. This is my new B right here. This is my new C. I'm going to trace that and rotate it 180 degrees clockwise. So here I go. I'm going to take that paper. I'm going to fill in these points. That is C, A, and B. I'm going to rotate it about the origin. That is the middle. So I'm going to draw my little orientation arrow right there. I'm going to rotate it this direction, half turn 180 degrees, and see where my new triangle is. So here I go. That's 90 degrees. Keep going, keep going. That is 180 degrees, a whole half turn. Fill those in. Again, the new A is the same exact place. My new B is right up here on the y-axis, and my new C is right here, again filling through the paper. So when I lift it up, there they are. This is the new C, this is the new B, and then that is the new A. So there it is. That is after shrinking it down by a half and then rotating 180 degrees. Number 6, it says which is true. If I look at them, congruent means equal. These are not equal. B says different, but I'm looking at them. Yeah, they're different, but you know, they look like they're proportionally the same, so I'm not going to choose that one. I'm going to choose C. These are similar. You can see this length is 4. This is half that 4. Half that 2, I'm sorry. This is 4. This is half of that. So these are two triangles shrunken down. They are similar. All right, 7. This problem has you find this angle right here using the supplementary rule. Both this 104 and this angle right here will add up to be 180. So if I take 180 and subtract 104, it will give me what that has to be to get a total of 180. So when I subtract, I get 76 degrees. Because again, 76 and 104 equal 180. So now all I have to do, this is called an external angle. This external angle is always made up of adding these two inside. Not this one right here. This angle is formed by adding these two up. So to find x, I just take 40 plus 76, and that gives me, if I do my arithmetic correct, 116, I believe, for x. All right, number 8, similar. These are equal angles. You could see by that opening, clearly equal. When you ever have a parallel line cut by another, these two angles are always equal. So if this is 70, B is 70. If B is 70, now I have enough to find A. Because again, remember, 70, this angle plus this unknown angle will equal 180. A lot of people could just do that in their head, but if I take 180 minus 70, I get 110 degrees. That angle has to be. So angle, that's the symbol for angle. Angle A is 110 degrees. All right, number 9. Of these, infinite number of solutions means when you're solving it, you would get 2 equals zeros. The only one that has that happen is this one right here. I know it's kind of weird, but at that point, if I took away 3x on both sides, I would be left with 0 equals 0. This, if I divide by 3, just gives me the answer x is 1, so that one is not good. This one right here, if I subtracted x on both sides, I'd be left with negative 2x equals 0, and that would give me an answer x is 0, so not that one. This one right here, if I subtract 3x, I get 0 equals 3, and that shows me no solutions, so that one is not correct either. But number 10, which is related to number 9, this is the only one that shows no solutions. Again, this one gives me an answer for x. This one right here also gives me an answer for x. Even though it's a little bit harder, I would subtract x on both sides and left with negative 2x equals 0, then divide by negative 2, which gives me x equals 0, so it's not that one. This one right here, if I was to solve it by subtracting 3x on both sides, that would give me 0 equals 0. That's the infinite solution one. This is the only one, if I take away 3x, I get 0 equals 3. That is that untrue statement. So this is the only one that shows no solutions. All right, number 11. Here you're just doing the regular math to solve for x. So I'm going to combine my like terms and then do variables on both sides. So this gives me negative 2x. Be careful, positive 3. Canceling away 3 of these negatives, I'm left with excess 2 negatives right here. Bring down the plus 3 equal 1 minus x. This is a variables on both sides. So step 1, start by getting rid of the number on the left side. Step 2 will involve subtracting or adding the x term. These cancel away. 1 minus 3 gives me negative 2. Know your negative rules. Minus x. Step 2, stay on this side of the equation. Leave that negative 2 alone. Get rid of that x term by doing the opposites. For this one, it's adding. So that cancels away. Careful, negative 2 plus 1x gives me negative 1x. Bring down the negative 2. And then right here, my third step, the opposite of timesing by negative 1, dividing by negative 1. Cancels away. That gives me x equals 2. All right, next problem. Here, I'm going to distribute. That gives me 3x minus 3, step 1, equals 5x plus 2. When you're distributing, you're timesing this times x and 3 all the way down times this negative 1. Now it becomes a variables on both sides. Start by getting rid of the plain number on the left side. Bring everything else down. Add 2 and 3 to get 5. The next step, stay over on this side. Get rid of the variable. So subtract 5x. This gives me negative 2x equals 5. And then the fourth step to this, the opposite of negative 2 times x is dividing by negative 2. Cancels away. Gives me x equals 5 over negative 2. Or you'd write that negative 5 over 2. Or you could write that 5 over and the negative right flush with the equal line right there, or the division line. All those are equal. All right, 13. This says translated for this. Well, first it's reflected across the x-axis. So that would be the new C straight across the new B, 3 above, 3 below, the new A. And then shifted over 1, 2, 3, 4, 5, 6 units to the right. 1, 2, 3, 4, 5, 6. So I'm going to change this to 6 because that's really what it should have been. I'm sorry about that, my mistake. So again, of these statements, some are true, some are false. It says after this transformation and then the second transformation, side AC is longer than this side right here, and you can see that is not true. Those are the same. That would be false. BC is the same as the new BC, and you could see clearly that is true. Angle B, inside here, this angle is equal to the new angle B, and you could see, yes, those are the same as well. So that first statement is false. Second two are true. All right, next. This one, it's going to have you translate 3 units left and then 2 units up. So let's go ahead and move each point. 3 units left. 1, 2, 3. 1, 2. That is the new A. Move this. 1, 2, 3. 1, 2. That is the new B. I'm going to put those little marks to show those are the new locations after the transformation. 1, 2, 3. 1, 2. This is the new C. And then after that, then I'm going to reflect across the x-axis here. So again, this is my first image, image number 1. This is the pre-image before the transformation. My last thing is to translate this directly across, reflect directly across the x-axis. So if this is B, 1 above, the new B, and I'll use 2 marks there, is 1 below. The first C for this image is 1 above. The new C for this second image is 1 below. I'm using 2 marks there to show. This one, 1, 2, 3, 4 above, 1, 2, 3, 4 below. That is the new A. So the question's asking, after I translate it, after I slit it over and up, and then I reflect it, what is this new coordinate for A? And I could see that is for X, -1 for X, and then from there, -1, -2, -3, -4. So -1, -4. So that new location after both those transformations is -1, -4. This is image number 2. All right, last problem. Again, -1, -4 for the new A. Last one. It says, here's my pre-image. I'm doing 2 transformations. So what I think I'm going to do here, it looks like maybe I'm reflecting it and then maybe sliding it. So I'm going to go that route. I'm going to see if I reflect over the x-axis what happens. So if I reflect it here, that gives me C. That gives me the new A. Down here I get the new B. Nope, that's not going to work for me. So why don't I try reflecting it over the y-axis. So if I have the C here, the new C right here, B right here, the new B, 3 other side, is right here. And then the new A, 4 to the left for the original, 4 to the right for my new A, and that would be right there. Sorry about that. So it looks like what I did, I first reflected over the y-axis, and then it looks like I take my triangle and just shift it down, which is a translation, shifting down 2 units. So that's what I'm going to write. First step, I reflected across the y-axis, straight across the y-axis. My second transformation, I translated 2 units down. You could have translated it 2 units and then reflected, but I'm going to go this route right here. So reflected across the y-axis and then moved 2 down. Good luck. I hope this video helps. I'll be here and there every day at lunch or break to help you.